y equals,
Give us the hardest we can think.
well, harder is if I put together shift and shrink and everything, but if I want to focus on the part that you're talking about, let me do that first. So let's go with cosine of 1/10 x. I'll make it a little harder. Just
Yeah.
Oh no.
It's better to practice harder and then.
Okay, how about that?
Okay.
I mean, I can make a whole harder problem altogether, but it doesn't focus on what you asked me.
Okay.
Okay?
Learning the hard stuff made me forget the simple stuff.
You what?
Learning the hard stuff made me forget the simple ones.
Well, this is medium. This is medium. All right, what does the 3 do?
Amplitude.
Changes the amplitude. So the amplitude is 3. That's easy to take care of, right? That just tells you how high up and down it goes. What does the minus out in front do? Yep, it flips across x-axis. It's a reflection across the x-axis. Now, most students know that, but I'll tell you. Oftentimes we'll write it there and then we'll forget to do it at the end. So that's why I wrote it in red. All right. The part that you were asking me is about this part right here. What does that do to it?
Makes the scale 10 times bigger?
It does. So it changes the period to 2 pi divided by what? 2 pi divided by b, which is 2 pi divided by
10?
the coefficient.
So that's something. For some reason, I was multiplying the period by like 10 or whatever was on the bottom to get x by itself.
That would make, well, okay, I see. That would make the period.
You would make a problem.
Yeah. So this would be what?
So let's see, 2 pi, 20 pi.
20 pi. So that's what you said. You said it in different words than I did, but you said this scales it to make everything 10 times larger.
Yeah.
So the period is 10 times larger. It's usually 2 pi, now it's 20
Oh,
pi.
I see. Okay.
So it does fit together with
That
what you
distorted.
said.
Okay.
Yeah.
Okay.
Now, why does it do this? Well, I was showing this to Patrick before class. Did it help or not? Is it worth me saying it or not? When I told you how the argument goes from 0 to 2 pi?
Yeah.
Does it help? Why this is because the cosine of x, regular, unshifted, unstretched, or anything, the period is 2 pi, right? So that means, whoops, let me call it theta. When that argument goes from 0 to 2 pi, that's one cycle. That's one whole cycle.
Okay.
Whatever the argument is, when it goes from 0 to 2 pi, that'll give me one whole cycle. So if the argument is something like this, so this is taking the role of theta there. When that argument goes from 0 to 2 pi, that's one whole cycle. So I've just said the same thing twice, right? But what does that mean about x by itself? If I want x by itself, what would I have to do to get it here? Divide by b. So x goes from 0 to 2 pi over b to give me one whole cycle. So this is one whole cycle, so this is one whole period. So this is the new period. That's where that comes from. So you have to divide by whatever that is, whether it's a fraction or a big number, divide by that to get the new period. Now with tangent and cotangent, oh, in that case the formula changes, right? Why does it change? Because if this was a tangent of theta, this would be a pi. So this would be a pi. So we would get pi divided by b. So it's the original period scaled divided by b.
Are we going to draw it?
Yeah.
Okay. So the next part about that when I get to checking is when I check my point on this one.
Okay.
Big graph.
All right. Well, yeah, it is a big graph, but it doesn't have to be, because if I change if my scale is like pi over 4, boom, 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 pi, boom, 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 2 pi, I'll be over on the other side, right? So pi over 4 doesn't make sense in this case,
Especially pi over
right?
5.
I mean, one cycle.
So one cycle is 5.
One cycle is 20 pi. So if I put 20 pi right here, say, that's one cycle. So I don't want to put, like if I put If I put pi right here, where's 20 pi? Way over there.
Yeah.
So it would be stretched like this.
We can start over here.
Start around there and go around the corner. So you want to make a scale that makes sense for this.
So we divide by 5.
5 pi is a good one. And not that you should memorize this, but typically a quarter of the period is a good choice. So a quarter of that is 5 pi. You don't have to use that as a scale. We could have used pi and spread it out. All right, so if I did 5 pi, then I would go 5 pi, 10 pi, 15, 20. The amplitude we said was 3.
And then reflect extension.
So before I flip it, a cosine would start at its high, right? And then it would go 0, high 0, low 0, high 0, low, every quarter period, every 5 pi units. But if I'm thinking ahead, I'll realize, oh wait, I'm going to have to flip that. So let me just flip it now. Instead of starting at its high, it's starting at its low. The only way you can go from here is up every quarter period. So 0, low, 0, high, 0, low, and so on. So what are these coordinates here?
10 pi.
Yeah, if you read your graph, 5 pi, this is 10 pi. So 10 pi, comma 3, oops. And this would be 20 pi, negative 3, and so on.
I know this is the easier one, but algebraically, if we drew our graph wrong, we wouldn't get the right point. So algebraically, how could we prove the right point? Like double check.
Yeah, well, that's what, I mean, so once I have this, this is where I'm always encouraging you to check a point. So we check it by plugging it back in. So y equals negative 3 times the cosine of 1/10 x. Our x here is 10 pi. And so we're saying that when we put in 10 pi, we're going to get out 3. So this is going to tell us algebraically if we really do.
Oh, okay, that's right.
1/10 of 10 pi is pi. What's the cosine of pi?
Negative 1.
Pi is over here. Cosine is the x value. Negative 1. So we get out 3, which is what we wanted to. Okay? For you to really appreciate how helpful it is to check, it's not very easy to appreciate it when we already have the right graph. It's when you see the check catch you, and you will, and I do all the time. I mean, look, the most common mistake on this one students make, and myself included, is even though I said right up there I'm going to flip it, I often forget to flip it. If I had forgotten to flip it, I would have labeled this point right here, 10 pi negative 3. And then when I went to check it, I'd go, okay, 10 pi, I'm expecting a negative 3. Oh, I didn't get one. What did I do wrong? And then I go back, oh yeah, I forgot to flip it. I just saved myself, 5 out of 10 points on the test because I checked points. Or more.
5 out of 10.
Okay.
Well, that was a good one.
So before you draw your scale, you want to get a feel for what's going to happen. It's like suppose I ask you to graph this. So think ahead a step or two. Would it make sense for me to draw a scale like this? No, because when I put in 1, it's already at 1,000, right? So it's already on the next floor. So you know that you're comfortable enough with that you know that. You're like, okay, well, wait a minute, these values are going to get big. Let me make these values big. That's what we're doing here. When we figure out the period, we go, oh, those values are going to get big, so we'll scale it accordingly. What else? Oh, you also wanted to see what with
tangent vertical. Are we going to have that on the final?
a tangent.
A tangent horizontal.
Yes.
We will. Can we do that?
Sure.
And just to confirm, if that would have been instead of 1/10 pi, 10 pi, then we would have done the exact same procedure.